All right, here we go. We were adding these two vectors A and B, and so algebraically, you can just take the components of each and add them up. So you can add the x components, and there's that, and then the y components. Ba-bam, great, that. So this is sort of like saying, if you want to visualize it, that this was the case. We wanted to take, let's color code them. We wanted to take this vector, right, which goes over 1 and down 3, and we wanted to add that to a different vector which goes over 4 and up 7, right? So 1, 2, 3, 4, and up 7. And so really you can just add up the over parts, right? And that becomes this, and the up parts, or the vertical parts, this and this, which just become this, the difference of which become this piece because one's negative. And then therefore you find the resultant vector from that, right? Great. We can do the same thing here. If you're subtracting, you just subtract the components. So the 3 minus 1. Oh, sorry. They got me. This is they wanted q minus p, so that minus that. So 1 minus the 1 minus 3 and the 4 minus negative 2. Just be careful of your negatives, and then also do the same for a 3 system. Just be careful of your negatives of how you're subtracting. Cool. Check those out. All right. I also want to be able to take a scalar multiplication. A scalar is not a climber. They scale things, right? A scalar is like scales things up or down. So here's an idea of here's a scalar, right? If you have one vector right here, if you multiply it, if you want twice as many, it's the same thing going in the same direction, starting from whence the other stopped, right? So if this is 1a, 2a is going to be twice as long in this direction and twice as long in this direction, right? So it's going from here to here is 1 unit up, it'll go twice as far up. And from here to here is 3 units over, this will go twice as far over. So 2 and 6, respectively. Cool? That's all scalar multiplication is, right? It just goes double this distance and double that distance. It's like adding it up twice. Cool. So if k is any scalar and you got v is this x and y vector, then kv is just going to be the multiplication of k into the x component and y component. All right, so take that idea and try p plus 2q, right? So p plus twice this, and also try half p minus 3q. Pause me and try that out. Go. Okay, so do your multiplication first. I think that makes it easier. So you get 4 and 6, and then add it to your 4 and 1, and you should get this mess. And then this, do the same thing. Multiply in. If the math gods are good to you, this becomes an even number. This becomes a half, and so you end up with 9 halves. And that's okay. If you're not sure about the fractions, come see me. All right. We also want to figure out the vector between 2 points. So here's point A. They give you a location for it, x and y. Here's point B. They give you a location for it, x and y. And we want to be able to find the vector between the two. If you look at the text, they make this really horrible, long discussion of it, with like flipping this around. That's like the distance between O and A, and the vector between O and A, and the vector between O and B. And you look at the difference between. Oh man, that's ridiculous. It made me very. I don't like how that is projected. So I just think about it this way. I think about if you're trying to go from this spot to this spot, all you really need to do is think about the change in the x and the change in the y, right? Make your own vector out of it. So how far up between here and here? Well, it's the difference in the y values, right? And those come from the vectors. So from here and here, right? The change in the vertical is just the difference between those two, and that's this piece, right? And the distance over from here to here is just the difference between these two, right? That's just these. Where do these points come from? They came from the vectors themselves, right? It's the vector how to get from 0 to this point, or 0 to this point. Oh, not 0. So this location is fundamentally the x value in the first vector. So you can steal them right from here. You don't have to graph them. Let me give you an example of that. All right. So they word these a little bit funny, and that's okay. We'll have to figure them out. So here's some given points. Bam, bam, bam. Find the position vector of B from O. Right? This means starting at O, how do you get to B? These get kind of fussy looking and like, oh, this is A really means the position vector of B relative to O. These get really fussy. The wording's a little fussy. Draw the stinking picture. Like, it's going to save you a ton of time. So here's O. And here's B. 3, 4, 1, 2, 3, 1, 2, 3, 4. There's B, right? 3, 4. If they want the position vector of getting to B from O, that's this, right? It's from here to here. Yeah? So how did you get there? You went, well, I went over 3 and up 4. Yeah? So the position vector should be 3, 4. They do this subtraction thing because we started at 0, 0, right? So let's take that idea and try this from B to A. How to get from B to A? Well, let me erase this mess. Oh, I guess our B doesn't need to erase. So here's B. It was at 3, 4, right? 3, 4. And A is -1, 2. -1, 2. So we want to be able to go from A to B, right? Just look at how far over you have to go, and then how far down you have to go, right? How far over you have to go comes from the x-coordinates subtracted, right? So that minus that, right? Which means, yeah, you have to go 4 units over, but in the negative direction, right? So that's where you get this from, this top piece. You're just subtracting the x's. You got 4. Oh, negative? A to B. Oh, A to B. This one's A, that one's B. Flip it. Cool. Sorry about that. So this should be +4. Okay, so here's B, here's A. Didn't read right. B from A. How do you get to B starting at A? Read right. So how do you get to B starting from A? You have to go +4, and you have to go up 2, right? Do the same thing from A to get to A from C. C is 4, 1, 2, 3, 4, and -5, 1, 2, 3, 4, -5. So here's C. It's at 4, comma, -5. And we want to do the same thing. We want to go to A from C. So 2A from C. Oh, my lines, my vectors are crooked. So if you're trying to find how to get from one to the next, you just start with the difference between the two here. I wanted to get from here to here. Look at the difference in the x's and in the y's, and you subtract them. That gives you the difference, right? And really, you're just looking at it as a right triangle. Yeah. Cool. So that's about it. So now you can talk about vectors in a plane. You know how to find their magnitude. You've done some operations with them, and we know how to find the distance between the 2 points, the vector between the 2 points. Cool. Try a couple of problems and see how you do, and we'll see you next time. Okay, bye.